After we learned how to find the slope of the tangent line, and we briefly introduced the concept of the derivative. Derivative of a function. And we kind of know that is the derivative of a function. There's several notations. There's several different ways to show that. They're all the same. Okay. Every time when you see that, you can write like f prime x. This is called f prime x, or you can say dy over dx. Okay. Or you can simply say y prime. Or there's another way you can do dx. Or some book like to use this. It's all the same. Every time when you see that, we talk about the derivative of a function x. And did you notice that the derivative of a function is also a function? Derivative of a function is also a function. Let me just focus this a little bit. It seems okay, much better. All right, and if you remember last time we did, I gave you one example is this, right? F of x equals, I believe it was 2x squared plus 3. And then we found f prime of x equals 4x. I don't know if you remember that. It was in my last class. Now, in today's class, we're going to do several more exercises. So I want you to get familiar with it and how to find the derivative of a function. All right, now the first one is if I give you f of x equals 4x plus 5. That should be just a linear function. And if you know the graph of this linear function looks like this, right? And that's a straight line. So what's the f prime of x? Let's see. Because you can imagine that for any point here, and what is the slope of the tangent line? It should be the same as the slope of this line. So it should be the same, 4, right? Let's see. So by definition, this is a limit. The f of prime should be limit delta x approaches to 0. And here is f of x plus delta x minus f of x over delta x. Okay, so that's the definition. Okay, go ahead. I have a limit delta x approach to 0 and the numerator. F of x is a 4 times of x plus 5. So f of this guy is going to be 4 times x plus delta x plus 5. This is this part, right? And I'm going to minus f of x, which is just the 4x plus 5. You probably already know that we're going to simplify and then we're going to cross out a lot of things. So that's a limit. Delta x approaches to 0, and the numerator, distribute that. I got a 4x plus 4 delta x plus 5. Okay, so I distribute this 4 into the parentheses and plus 5. I'm going to minus a 4x and minus 5 over delta x. Now I'm going to cross out this 2, and I'm going to cross out this 2, right? So I only have a 4 delta x left. Divided by delta x, I should get a 4. Has nothing to do with the delta x, so it's always a constant 4. So f prime is a 4. So this is easy, and that also agreed with what we just talked a little earlier, right? So we can find the slope there, or we find the prime, or we find the derivative. All right, so next example is this f of x equals, I try to make it complicated, x to the third plus 5x minus 1. Okay, so by definition, f of prime of x should be limit delta x approach to 0 f of x plus delta x. See, I'm not tired of writing this. I write this all the time because that will help me. And then I'm going to go ahead and limit delta x approach to 0. Okay, now the top f of something should be something cubed plus 5 of something minus 1. So that would be x plus delta x cubed plus 5 times x plus delta x minus 1. So that's the first part. And then minus, the second one is just x to the third plus 5x minus 1. Now that over delta x and delta x approach to 0. Okay, now we have this cube. And if I give you, I don't know if you remember this formula, a plus b to the third. Of course, you can do a plus b times a plus b times a plus b, but I think I'm going to do, I'll give you the formula here. That's going to be a to the third plus 3a squared b plus 3ab squared plus b to the third. Okay, so I have, here's a, here's b. Therefore, I get x to the third plus 3x squared delta x plus 3x delta x squared plus delta x to the third. 1, 2, 3, 4. These are 4 terms. It's the expansion of that one. And then I'm going to go ahead plus 5x plus 5 delta x minus 1. I go ahead and distribute this negative sign, so I get a negative x to the third, negative 5x plus 1. Oh my goodness, this is just too much paper. Alright, I know I'm going to cross out all the things. See? This is gone. Okay, so I have this one. This one will be crossed out. And there is a plus 1. Minus 1, it's gone, right? Okay, so let's see. Limit. Let's see what I have left. I have something about delta x. See, here has a delta x. Here has a delta x cubed. Here has delta x squared. Here has a delta x. So I get 3x squared plus 5. Okay, I take out the delta x because later I can just cross out the denominator, right? And then for the next I just copy because there's really not too much I can combine. Delta x squared. And then plus delta x cubed. Now, and then when delta x approach to 0, first of all this is gone. So I have this part, 3x squared plus 5 has nothing to do with the delta x. No matter how close it is to 0, so it's still 3x squared plus 5. And then this part, delta x squared over delta x, you only have one delta x. When delta x approaches to 0, then this product approaches to 0. And when delta x cubed over x, you get a delta x squared. And then when delta x approaches to 0, it's also 0. So this is your answer. That's your alpha prime x. Okay, so if you have like a higher powered polynomial, like higher than square, don't worry, you can just be patient and then use this limit process. You can get it, no problem at all. Alright, now we did the square, we did a linear, we did a cube. I'm gonna ask you to, I'm gonna do a couple of more. Okay, one is this, one is square root of x plus 5. This is the radical function. So find f prime. That will be, again, limit delta x approach to 0, f of x plus delta x minus f of x over delta x, right? That's exactly what we want to do. So I have a limit delta x approach to 0, and I get delta x. And then the numerator, I have a square root of x plus delta x plus 5 minus the square root of x plus 5. Now, you got a small problem here, because when delta x approaches to 0, your denominator is approaching to 0. But your numerator, when this part approach to 0, so this part approach to x plus 5, if you minus the square root of x plus 5, you also get a 0, something really, really close to 0. So in this case, you cannot just get the answer as easy as you want. So what I'm going to do is I'm going to ask you to multiply by this plus that. And the reason is because both have a square root. But if we have a plus b and a minus b, the formula will be a squared minus b squared, right? So in that case, if I have a square root here, square root here, and then if I multiply by almost like the conjugate, I shouldn't call it conjugate, but it is the square root of something minus another one, you get something square and minus another square. What happened is that square root is gone. So it's going to be x plus delta x plus 5 plus x plus 5. So the denominator is going to be, I have to multiply by the same thing. Okay. That's literally I'm multiplying by 1. Right now. Limit delta x approach to 0. Now the numerator, like a minus b times a plus b, I should get a squared minus b squared. And a squared, which is the square root of this term, then square, I could just get x plus delta x plus 5. I get this square root and then square, right? And let me just write one more step. So that would be x plus 5. Okay? And then divided by, we're going to delta x multiplied by x plus delta x plus 5 plus x plus 5. Looks complicated, but it's not too bad. We'll see. So I got a limit, and the delta x approach to 0. And the numerator is x plus delta x plus 5. Square root then square, right? And a minus square root then square, so that's x plus 5. And here's delta x and x plus delta x plus 5. So square roots. Okay, so the numerator x and this negative x get cancelled, so this is cancelled. So the numerator, I only have a delta x, but delta x will cross out with the denominator, so that will be just 1, right? This cross out in just 1. So that will be this. Limit delta x approach to 0, and the numerator is 1. Denominator will be, this is gone, so it's going to be x plus delta x plus 5 plus. Alright, now delta x approach to 0, so this part goes to 0. And so I have a square root of x plus 5, and here's another one. So I will have 1 over twice of square root of x plus 5. Right? Delta x approach to 0. So this part approach to 0. Just substitute 0 here. And then you're going to get twice of this much. Of course, you don't want the square root in the denominator. You're going to rationalize it. So 2 times x plus 5 the square root of x plus 5. So you're literally multiplying by square root of x plus 5, both numerator and denominator. So you don't have the square root sign in the denominator. So that's the f prime of x. See, that's another function. It's just the derivative function of f of x equals square root of x plus 5. Now, we did a linear, we did a quadratic, we did a cube, and then we did the square root. I think another one is rational. I want to put an x in the denominator. You're going to see what happened. So one more example. I give you f of x equals 5 over x. Then find f prime. That is limit delta x approach to 0. F of x plus delta x minus f of x over delta x. I think you should be really, really familiar with this formula right now, with this definition right now, right? So delta x approach to 0, let's see. F of x plus delta x. That's this one. And I'm going to minus 5 over x and over. I need to find the least common denominator, right? Because here. So I get a limit delta x approach to 0. The least common denominator should be x plus delta x times x. It should be the product of these two. So the numerator, when this becomes this, you multiply by x, so you should multiply by 5x here. And you're going to minus the same denominator, x plus delta x times delta x. Here's going to be 5 times x plus delta x. That's how it worked. Divided by delta x. So don't be scared, okay? We can find it. Don't worry. Limit delta x approach to 0. Alright, now we have the denominator and the numerator should be 5x minus, I distribute this into that, minus 5x minus 5 delta x. That's the numerator part, divided by x plus delta x times delta x. So x. Okay, so that's the numerator. And the denominator, I just write delta x like that. Because a over b should be the a times 1 over b, right? So I just write it this way. And then 5x gone. And then delta x gone, you get a negative 5, did you? So the numerator, you get delta x approach to 0. The numerator, I get a minus 5. Denominator, I still have x plus delta x times x. Alright, now when delta x approach to 0, then this is just x plus 0, it's just x times x. So negative 5 over x squared. What do you think? I told you that as long as you're not scared and you just use this approach and pay attention to it step by step, you should be able to get it. So I think that's all we're going to use the limit process to find the derivative of function. And I give you all the examples, all different kinds of examples. I did linear, I did quadratic in the previous session, I did a cubic function, and also I did the square root, and also I have this rational, that which means x in the denominator. I think that pretty much covered most of the thing you learned before. Not for the trigonometric function and exponential and the power function. We're going to deal with them much later, but so far this I think you're okay with this, and then you can just go ahead and